Are you interested in the effects of urban heat islands? Our summary today works with the book chapter titled Synergies and Exacerbations, Effects of Warmer Weather and Climate Change from 2023 by Hassan Saeed Khan, Riccardo Paolini, and Matthaios Santamouris, as part of the Urban Climate Change and Heat Islands book, published by Elsevier. This is a great preparation to our next interview with Matthaios Santamouris in episode 322, talking about the urban heat island effect, its causes, and potential solutions. Since we're investigating the future of cities, I thought it would be interesting to see the complex interplay between urban overheating, heat waves, and weather conditions. This chapter aims to understand the synergies between these phenomena and their implications for urban communities.
What is the future for cities? Do you want to learn more about them? Do you want to know how others think about them? Do you want to be part of the conversation? Then this is the right place.
Welcome to today's What is the Future for Cities podcast and its research episode. My name is Fanny, and today we will introduce a research by summarizing it. The episode really is just a short summary of the original investigation, and in case it is interesting enough, I would encourage everyone to check out the whole documentation. This conversation was produced and generated with Notebook LM as two hosts dissecting the whole research.
We're talking all about urban overheating and heat waves, but we're not just going to cover the basics today. We're really going to try to go beyond just saying that cities are hotter, and we're going to dig into why some cities get much hotter than others during heat waves. Some urban areas just become these furnaces while others do okay.
And that's the question that researchers are really trying to figure out. And honestly, it's way more complicated than most people think.
Yeah, I bet.
We'll be looking at a chapter from the book Urban Climate Change and Heat Islands today. And this chapter focuses on how warmer weather and climate change are really making these urban heat problems even worse.
Okay, so we all know that cities are hotter than the areas around them. That's that urban heat island effect, or UHI.
Right.
But it's got to be more than just all the concrete in a city, right?
Yeah, it's not just about how dense a city is.
Okay.
You might think that a city with a ton of skyscrapers would be the hottest, but that's not always true. Sometimes sprawling suburbs with lots of asphalt can be just as bad or even worse. It really comes down to the types of development, the materials that are used, and how all that impacts the way that heat is absorbed and released.
So if you had a cast iron skillet and a nonstick pan, they both get hot, but the cast iron is going to hold that heat for much longer.
Exactly.
But what about those cities that just seem to deal with heat waves better? Are they just lucky, or is there something else going on?
Luck might play a tiny role, but the real difference is something called synoptic climatology.
Okay.
Basically, it's the study of weather patterns on a large scale, how big masses of air move and interact. It's the conductor of the heat orchestra.
Wow.
It influences things like the wind patterns, humidity, cloud cover. All of that can either make the urban heat island effect worse, or it can provide some relief.
Okay, my mind is already blown, and we're just getting started. So to recap, we've got the urban heat island effect, and we know that it's not as simple as just concrete equals hot. Then we've got these heat waves that come in and make everything worse. And on top of that, we've got these big weather patterns that act like a wild card. Sometimes they make things worse. Sometimes they make things a little bit better. Did I get all that right?
Yeah, you got it.
Great.
And to really understand how all these things come together, we wanted to think about the energy equation.
Okay.
So imagine a city on a hot day. The sunlight is pouring in, and that's your radiative input.
Okay.
The black asphalt roads are super hot, and that's sensible heat transfer.
Okay.
And then suddenly a breeze kicks up, bringing in cool air from the coast, and that's called advection. And it changes the heat balance.
So wait a minute. It's like there's a giant spreadsheet for tracking heat in the city.
Yeah, basically.
But how do you account for everything? What about something random? If there's a sudden downpour or a flock of pigeons flies over and blocks the sun?
That's a really great point. Cities are so complex. And while we have that energy budget equation to help us understand the big picture, those little details can really have a big impact. Something as small as the color of a roof can change how much heat is absorbed.
Oh, are you saying that if we painted all the roofs white, we could cool down a whole city? I'm ready to sign up for a citywide painting party. But seriously, are there cities that have actually done things to beat the heat?
Yeah, there are definitely cities that are getting creative. They're doing things like green roofs, special pavements that don't absorb as much heat, even planting more trees in cities. But to see how this all works in the real world, we're going to look at Sydney, Australia.
Okay.
It's a really good case study because it's your typical coastal city, but it's got this extra challenge, those super hot desert winds that blow in from the outback.
Ooh, so it's two different climates fighting over one city. Sydney's geography is so unique, and those dueling weather influences, oh man, that makes it a fascinating case study. For sure.
Absolutely.
It's like someone just turned up the difficulty level on a SimCity game.
Yeah.
You've got the ocean breezes versus these crazy desert winds. That's got to be a challenge for anyone who's planning a city. But before we get into the specifics of Sydney, I'm curious about those other cities we mentioned earlier, the ones that just seem to deal with the heat better. What are they doing differently?
There's not like one secret trick or anything, but a lot of them are focusing on cutting down on what we call anthropogenic heat. Basically, that's the heat that we humans make. Think about it. All the cars, factories, AC units blasting during a heat wave. We're adding another layer of insulation to a city that's already way too hot.
So we're not just dealing with the heat from the sun, but also the heat we're making ourselves. That makes a lot of sense. But wouldn't a bigger city have more resources to fight the heat? Are we saying that the size of a city is like the most important thing?
That's a great question, and it really shows how complex this whole thing is. A larger city might have more resources, yeah, but it also has more people, more builders, more infrastructure, and all of that makes that anthropogenic heat even worse. It's like a balancing act. And the cities that are doing are usually the ones that are looking at everything, the way the city's designed, the transportation systems. They're even doing public awareness campaigns to try and get people to think about the heat.
So a good urban planner needs to be like a heat detective, right? They got to figure out all the little things that make their city unique when it comes to heat. But how do they even measure and compare all of that stuff?
That's where things get even more complicated. There's no one standard way to measure urban overheating. And because there's all this different research out there, it's really hard to compare the results. Some studies focus on the temperature of surfaces, others look at the air temperature. Those can be very different, especially at night.
Oh, yeah, that makes sense. We were talking about how cities are like giant heat sinks.
Yeah.
They soak up all that heat during the day and slowly release it at night.
Exactly.
So you could have a situation where the air feels super hot and sticky, but the ground is actually starting to cool down. That would make it hard to sleep.
Exactly. And it gets even trickier when you think about how those temperatures are averaged. Some studies use hourly readings, others might use daily or even monthly averages. But if you look at it over a long period of time, you might miss those quick changes in wind patterns that can really make a difference. Sometimes those changes can cool things down. Sometimes they can make the heat even worse.
So it's like trying to understand why the stock market crashed by just looking at yearly averages. You'd miss all the crazy ups and downs that happen during the year.
That's a great way to put it.
And so it sounds like we have to be careful about how we look at these research findings because different methods can give you different answers. But isn't there at least some agreement on what a heat wave is? That seems like a good place to start, right?
You'd think so, but even there are differences.
Oh, no.
Some studies just use a simple temperature cutoff that's over 90 degrees Fahrenheit for 3 days in a row. They call that a heat wave. But others use percentiles, so they look at what the normal temperatures are for that place and that time of year.
So a heat wave in Phoenix is going to look a lot different on paper than a heat wave in London.
Exactly.
Even if the temperatures are the same, it's like they're using completely different rulers.
Exactly. And then how long the heat wave lasts also changes from study to study. Some say it has to be 5 days of really hot weather in a row. Others only need 3 days. So a short but intense heat wave might count in one study, but not in another. It's hard to compare them directly.
This is making my head spin. It's like trying to do a jigsaw puzzle where the pieces keep changing shape.
Yeah, that's a good analogy.
Oh, man.
It really shows why it's so important to look closely at how the research was done when you're reading about urban overheating and heat waves. Even those tiny details about how they define and measure these things can have a huge impact on the results.
So we need to be smart about how we use this information, right?
Right.
We need to be asking questions like, how did they measure the heat? What was their definition of the heat wave? Did they think about all the different factors that could be involved, both locally and in the bigger region?
Absolutely. And it's important to remember that this is a really complex area of research, and it's constantly changing. We're still learning so much about how cities react to heat waves. Those differences in the research, that's often because we're still figuring things out.
Okay, so context matters, the methods matter, and we need to be patient while scientists are still putting all the pieces of this urban heat puzzle together.
We've talked about how tough it is to measure this stuff and how the research isn't always clear and how even the tiniest details can make a huge difference.
Right. But now I want to hear more about Sydney. What did they actually find when they really looked at how heat affects this city?
Remember those two different weather forces we talked about, the cool sea breezes and the super hot desert winds?
Yeah.
Researchers looked at temperature data from all over Sydney, and they wanted to see how those competing forces affected the city's heat.
So they didn't just look at Sydney as one big thing, they broke it down to smaller areas.
Exactly. They wanted to see how that urban heat island effect worked in different neighborhoods. They looked at how close those areas were to the coast and how much those outback winds affected them.
Okay, that makes sense. So what did they find? Did those desert winds just turn the whole city into a frying pan?
Not quite. What they found is that over half the time during the day, all three zones of Sydney were experiencing that urban overheating.
Okay.
The eastern coastal area, inner Sydney, and western Sydney. But here's the interesting thing. At night, for 90% of the time, they actually saw the city getting cooler.
Hold on. So the suburbs were actually cooler than the city center at night?
Yep.
That doesn't sound right. I thought cities were always worse at night because all that heat gets trapped.
You're right. That usually happens in cities. But in Sydney, those inland suburbs have more natural surfaces than the city center, which is packed with buildings.
Oh, okay.
And that means those suburbs can cool down better at night. It's like those grassy backyards and tree-lined streets are acting like little radiators, releasing heat back up into the air.
So even when there's a heat wave and those hot desert winds are blowing, the suburbs of Sydney can still get rid of some of that extra heat at night. That's amazing.
It is. And this nighttime cooling effect is even stronger when the weather is dry and warm, when there are clear skies and the wind is calm. Those are the perfect conditions for something called radiative cooling.
Okay.
Remember when we were talking about that energy budget? When there aren't many clouds and the wind isn't trapping heat, the ground can release that stored energy back into space much easier.
So it's like the whole city is taking a giant exhale after a long, hot day.
That's a great way to put it.
Thanks.
But of course, this cooling doesn't happen the same way all over the city. While the suburbs are getting that relief at night, the city center, with all its concrete and asphalt, is still holding on to that heat.
So it's almost like a paradox. During the day, the city center, which is usually the hottest part, gets a little cooler because of those sea breezes. But then at night, it flips and it becomes hotter than the suburbs.
You got it. And this just shows how important it is to understand those little differences in how heat affects a city. Even in one city, different areas can experience heat in totally different ways. It all depends on how close they are to the coast, how much vegetation there is, and those big weather patterns we keep talking about.
Okay, so we've got this super intricate dance between the things happening locally and the bigger weather patterns that are all influencing how hot it gets in Sydney. But how did researchers actually link those specific weather patterns to those changes in heat? It's not like they can just look up and say, oh yeah, this is definitely humid and warm weather type number 3.
That's where things get really interesting. Researchers use something called a weather typing classification system. Basically, it's a way to categorize different kinds of weather systems based on their characteristics. Things like temperature, humidity, which way the wind is blowing and stuff like that.
So it's like they're giving each weather system a personality test.
Yeah, you could think of it like that.
Cool.
And by comparing these different weather types to how the heat was changing in Sydney, they were able to figure out which weather systems were making the city hotter and which ones were actually helping it cool down.
Which weather types really turn up the heat in Sydney?
During the day, the ones that made the urban heat island effect worse were the humid and warm weather types.
Okay.
They often come with tropical time air masses. These systems basically reduce how much matter evaporates, which means there's less of that natural cooling effect you get from plants and water. And that can really intensify the urban heat island effect, especially in those inland areas that are far away from the coast.
So those humid and warm weather systems are like a giant sauna for the city. They trap the heat and make it feel even stickier and hotter. What about the opposite? Are there any weather types that actually bring some relief to Sydney?
At night, those dry and warm weather types, the ones that usually come with tropical continental air masses, were the ones that helped create that strong urban cooling we talked about.
So basically, those drier air masses with their clear skies and calm winds are helping the suburbs of Sydney get a break from the heat. It's like Mother Nature is turning on the AC just for them.
Exactly. And this link between these big weather patterns and urban heat isn't just something in Sydney. Research in other cities all over the world has shown that these large-scale weather patterns play a big part in controlling the urban heat island effect.
So it's like these weather systems are setting the stage. They're creating the conditions that can either make the heat in our cities much worse or help cool them down a bit. This is all starting to make so much sense now.
It really highlights why urban planners and policymakers need to think about these larger weather patterns when they're coming up with ways to fight urban heat. It's not just about planting more trees or using lighter colors on buildings. We need to think about how our cities are interacting with the bigger climate system.
It's like we've been so focused on the individual ingredients in our urban heat recipe that we forgot to think about the heaven itself.
Exactly. And we also need to remember that urban overheating isn't just an environmental problem. It's a public health problem, an economic problem, and a social justice problem.
Yeah, that's important.
The people who are most affected by extreme heat are often the most vulnerable. And we need to make sure they're protected when we're trying to create cities that can handle the heat better and are fair for everyone.
This deep dive has been incredible. We started with the basic science of urban heat islands and ended up exploring this complex relationship between urban design, heat waves, and those fascinating large-scale weather patterns.
We've seen how those differences in research methods and the unique features of each city make it a real challenge to understand and deal with urban overheating.
But the biggest takeaway is that this is a real issue with serious consequences for people, the environment, and our economy.
And it's something we need to pay attention to and do something about. As cities keep growing and the climate keeps changing, understanding and tackling urban overheating is going to be essential if we want to create cities that are livable, sustainable, and fair for all.
So listener, what are your thoughts after this deep dive? What questions do you have about the future of our cities and how we can design them to better handle the heat as the climate changes? Keep learning, stay involved, and let's all do our part to make our cities cooler and healthier for everyone.
What is the Future for Cities podcast?